this experiment, I'm going to demonstrate how to use a semicircular glass block to find a critical angle. The apparatus that will be used is semicircular glass prism, protractor, 4 optical pins, pencil, plain paper, thumb pins, and drawing board. Procedure: place a plain paper on top of the drawing board and use thumb pins to stick it so that it will not move. Place the semicircular glass prism at the center of that plain paper and draw an outline around that one. Remove it and find the center of that outline and call it P. Use a protractor to draw a perpendicular line from that point P. And this perpendicular line will be called normal. Then use a protractor to draw an angle of 30 degrees with that normal. This line will be called line of incidence. Stick 2 pins on that line of incidence and this will make an angle of 30 degrees. Replace the semicircular glass prism on top of that outline and from the opposite side of that pins, view through that glass prism to see the images of the 2 pins which is placed on that incident ray. Then place another pin so that it will be in line with the images of P1 and that of P2. Remove the glass prism and then the other 2 pins and draw a line to join to that point P. Measure that angle with the protractor This angle is equals to 49. So this angle is called angle of refraction. repeat the same procedure for the angle of incidence equals to 40 by using another plain paper. So we place that plain paper, we draw the outline of the glass, semicircular glass prism. Find the center of that one so as to draw a perpendicular line from that. By using a protractor, draw that line to bisect it, which will be a normal, and that point P there. Then measure that angle of 40. Again, stick the two pins, that is P1 and P2, on the line, which is the incident ray. Replace the glass, semicircular glass prism again. On the opposite side, view through that semicircular glass prism so as to see the images of P1 and P2 inside that semicircular glass prism, and make sure that this will be, the images will be in line with that pin which you are going to place it. So while looking through that one, when you go in one side you may see the two pins, when you go in the other side you may see the two pins, but at a certain point the images will be blocked by those pins which you have been placed there. So after that, remove the semicircular glass prism and again the two pins, and draw a line to join the two points with that point P. Okay, use a protractor to measure that angle. This will give an angle of 70. Measure that angle of 45 degrees. That is the angle of incidence. Place two pins on that line. replace the glass prism. Then again, view through that glass prism so as to see the images of the two pins. Okay, then remove the glass prism, and from this experiment, this now it is on the opposite side of that one, showing that this one it is not refracted but it is reflected. This undergoes total internal reflection. Measure that angle. From this experiment, this angle is 45 degrees. Then remove the pins and replace another plain paper. Draw the outline the same. Locate the center width so as to draw a normal. Use a protractor to draw that normal. This time, measure the angle of incidence equals to 42 degrees. Then, stick the two pins on that line of incidence. And again, replace the semicircular glass prism on that outline. The same through that semicircular glass prism. View through that so as to see the images of the two pins. This time, it is a little bit difficult to locate that one, but you may try a lot. Now, according to this experiment, critical angle is the angle of incidence where that angle of refraction is equal to 90. Due to this experiment, we found that the angle which gives the angle of refraction equals to 90 is that angle of 42 degrees. And therefore, the critical angle of this semicircular glass prism is 42 degrees. Thank you.